this video with our introduction to statistics. By the end of this video, you should be able to determine the effect of outliers on data and be able to calculate the mean, median, mode, and range for a set of data. All right, so here we go. So what is statistics? Statistics is the process of collecting, organizing, analyzing, and interpreting data. So one of the things for when we're analyzing is we want to look at measures of center, and our most typical measure of centers that we look at are our mean, median, and mode. And so a measure of center is if you're wanting to describe where the middle or the typical value in a data set is. So there's some review information here. So a mean is an average. To find the average, you're going to add up all the data values and then divide by the total number. So if I add up 15, 7, 24, 13, and 21, so we're going to add all these together, and you would get 80, and there's 1, 2, 3, 4, 5 values, so the average number is 16. Okay, so try this one. Add them all up and divide by the total number of numbers, and let's see how you do. So if I go to add all these up, I got a total of 56, and there's 8 numbers, so the average there, meaning the average number, the typical number, is 7. All right, so we're pretty familiar with averages because of how grades work, and we have a pretty good idea about that. Another number that represents the center of a data set could be the median, and the median is the middle value. Now to look at and the middle value, you need to make sure your data is put in order. So we're going to put it in order from the smallest number to the biggest number, and then you're going to find the middle. And that is going to be your median. So if there's an odd number of numbers, the middle is very easy to find. So let's take a look at this one. So if we put this in order, I get 7, 13, 15, 21, and 24. So there are 5 numbers, 1, 2, 3, 4, 5. There's an exact middle when you have an odd number of numbers. If I put a box around this to kind of help you see it, 15 is the middle number because there's 2 numbers to the left and 2 numbers to the right. So our median is 15. But what happens if you have an even number of numbers? Because there's not an exact middle. So we're going to put them in order. So I got 2, 3, 5, 5, 7, 8, 12, 14. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the middle would be around at the 4th number. So 1, 2, 3, but it can't be this number because then there's only 3 numbers to the left and 1, 2, 3, 4 numbers to the right. So really where it's occurring is the very middle is right here between these 2 numbers. Then I've got 4 numbers to the left and I've got 4 numbers to the right. So I need to make a number to be the middle, and it's always going to be halfway between these 2 numbers. And the way we would find out what the halfway point between those 2 numbers is we would just add them and divide by 2, and I will get 6. So the median for this second data set is 6. The very middle number. It's kind of easier to see it when they're real close together, but if the numbers are farther apart, it's not as obvious. So adding them up and dividing by 2 will give you your answer. Now our last concept was mode, and that was the most often, the number that occurs most often. Okay, and so when we have a data set, we can have one mode, several modes, or no mode. If no numbers repeat, there's no mode. If you have a couple different numbers that repeat the same number of times, there can be more than one mode. Okay, so let's take a look. When I look at my first data set, I see none of the numbers repeat. So I don't want to leave that blank, but I don't want to write 0 as in there's 0 mode because 0 is an actual number. So we want to just write there's no mode. Okay. Now let's take a look at number 6. When I go through, I see, oh, right away I see there's 2 5s. Oh, there's another 5. So there's 3 5s, but I want to make sure there's nothing else that repeated 3 times, and there isn't. So my mode here is 5. And on number 7, let's take a look. I see these 2 7s repeated. I don't see another 7. Did anything else repeat 2 times? And when I'm looking, I see that there's a 10 and a 10. So I actually have 2 numbers that repeat twice. So I'm going to have 2 modes. I'm going to have 7 and 10. All right, let's continue on the back. So if we're talking about range, range is the difference between the largest and the smallest data values. So you'll just take the largest minus the smallest. Okay, largest minus smallest. That's really what you're doing. So when we look here at number 8, I'm going to look for the biggest number. The largest number is 24. And then the smallest number is 7. And 24 minus 7 is 17. So the range is 17. It's just telling you how wide is the data. Now by itself, that might not be a very helpful number. But if I start to make comparisons, it could be a little bit more useful. Let's look at number 9. And my biggest number, when I'm looking, it looks like 14 is the biggest number. And then the smallest number is 2. 14 minus 2 is 12. So this data set has a range of 12. Now I could say, looking at these 2 data sets, whose numbers have more, are more spread out? And you'd say, oh, well, this data set, because it has a larger range. So it's a little more helpful when you're talking in relation to something else. We're not going to worry about the practice because you've pretty much already done some of that. But let's take a look at our outliers here. An outlier is a data value that is much larger or much smaller than the other values. Soon we'll talk about how do you determine something that is much larger. How do you decide what that number is? There's a way to do that, and we'll talk about that later. But it also has an effect on the data, the numbers that we would report about the center of the data, and maybe which number we want to use. So let's find the mean median mode of this set of data with and without the outlier. So when I look at it, I look at all these numbers. They're a lot alike except for 50. 50 is very different. It's much bigger than all of the other numbers. So if I put them in order, I get 10, 11, 12, 14, 15, 16, 17, 17, and 50. All right, what I want us to do is I want us to find the mean, median, and mode with and without the outlier. So to find the mean with the outlier, we're just going to add them all up. And when I add them all up, I got 162. And there are a total of 9 numbers. So I'll get a mean of 18. So the mean with the outlier is 18. So let's go and do the median real quick. So there's 9 numbers, which is odd, which means there's an exact middle. So one way we can kind of look is we can kind of block these off as we go into the middle. It's symmetrical from both sides. 15 is the exact middle number. So I'm going to say my median with the outlier is 15. And then the mode, when I look, there's 2 17s and no other of the other numbers repeat. So the mode is 17. All right, so let's get the mean without the outlier. Okay, so really, I'm going to cover 50 up, and I want to know what that mean is. So add them all up, and when I add them all up, I got 112. Now there's 8 numbers because I took the 50 off, and that will give me a mean of 14. Okay, so now the median, remember we're not going to be looking at the 50. So if I just kind of ignore that, now there's 8 numbers. So the very middle of it is, we want 4 numbers on both sides. So 1, 2, 3, 4. So my median is going to fall right here. Halfway between 14 and 15. Well, halfway between 14 and 15 is 14.5. And then there's still 2 17s, so the mode is 17. So which measure of center was most affected? So when I looked, the modes didn't change. The medians changed a little bit by like half a point, but the means changed a lot. So the mean was a lot more affected. All right. And so how is the range affected? I didn't even ask you the range. So the original range is, with the outlier, is 40. Without the outlier, it goes from 10 to 17, so it's only 7. So it went from 40 to 7. Okay, so our mean is greatly affected when we have outliers. Think about a test. If you have some really good test averages and then you have one really bad test, what happens to your test average? It gets dragged down very quickly, but the middle of the numbers doesn't change that much. So if we want to describe the middle of a set of data, we would want to use the mean if there are no outliers. That would be the best representation of the middle. We would want to use the median to talk about the middle if there are outliers. Or there are no gaps in the data. No big gaps, really, I should say. Okay. You don't use the mode very often to describe the center, and that's the only time you'd really do it is if there are many repeated values. All right. So let's just take a look and see what we can do with this. So if we look at the typing speed here, and so words per minute, how many words per minute can these students in a computer class type? So I have a string of numbers, and when I look at them, one of the numbers really stands out to me as being very different than the rest of them, and it's this 22 here. It is much lower than the rest of them. So to me, that's probably an outlier. And again, like I said, we'll talk about how to calculate whether something's an outlier or not. But it's far outside all the other numbers. So I wouldn't want to use the mean because that's not going to be the best representation of the center of the data. I would want to use the median to find the center. And so if I take that number, I'm not going to have to take it out. That's the, we don't have to worry about taking numbers out if we adjust because there are outliers. And I'm going to put everything in order. So we have 22, 42, 44, 45, 48, 54, 56, and 60. So there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the middle means I need to have 4 on each side. 1, 2, 3, 4. So here's my middle right here. 1, 2, 3, 4. So I want to know what number is halfway between 46 and 48. Or sorry, 45 and 48. So we can add 45 to 48 and divide by 2. And you'll get a median of 46.5. Okay. All right, so take a look at number 3. Do we have anything that's out of line, much larger or much smaller than any of the other numbers? So when I'm looking, they're all kind of the same. And so because they're all about the same, we can go ahead and use the mean because there's no outliers. Right? So if we add up all those numbers, I would get 133.8, and there's 1, 2, 3, 4, 5, 6 of them. So the mean here is going to be 22.3. All right, let's keep going. All right, how does the mean change the data? So here I have a set of data about the cost of a wreath. And so we want to answer the questions below. So we want to find the mean, median, and mode of the cost of the wreaths. So do that on your own and come back and check. All right, for mean, median, mode, for mean, when I added everybody up, I got 294, and there were 7 data values, so I had a mean of $42. I put all of the numbers in order, smallest to biggest, and there were a total of 7, so there was an exact middle. And I can tell because there's the same number of numbers on each side. There's 3 to the left and 3 to the right. So 39 is my median. And the number 39 happened twice. It's the only number that was actually duplicated. So my mode is 39. So number 6, if there's an outlier, how does removing it affect the mean, median, mode of the cost per wreath? So the 18 looks to be an outlier to me because it's a lot lower than all of the other numbers. So what I want you to do is recalculate mean, median, mode by taking 18 out and come back and check to see how you did. Once I removed 18, I was able to add up the total wreaths to get 276. Now there's only 6 wreaths because I took out the $18. So the average there, the mean there is 46. I recalculated the median, which falls, because now there's 6 numbers, it's falling between 2 numbers because it's even. So the median is $43.50 and the mode is $39. All right, for number 7, I want you to look. It says the 2 most expensive wreaths are out of stock. That means they don't have them, so they can't sell them. What's going to happen to the mean, median, mode per cost of wreath? Calculate that and come back. So I removed the 2 most expensive wreaths, add them up for 179 divided by 5. I got a mean of $35.80. Median is 39 when I put everybody in order and circle the center one, and the mode is still 39. So 8 and 9 kind of go together. So I want you to go and calculate if we added $8 to each wreath, that means they're going to cost each $8 more for each one. What's going to happen to the mean, median, mode? So take each wreath plus $8, okay? And then 9, and so you're going to calculate mean, median, mode with $8 added to each wreath. So number 9 says if the shop is offering $5 off each wreath and free shipping, so now there's no shipping, how does this affect the mean, median, and mode? So there's no shipping and they are $5 less. So you're going to take each wreath price and you're going to subtract $5 from each one and then calculate your mean, median, mode. Go ahead and do those and come back. All right, so looking at number 8, we're charging an additional $8 to every wreath. So we took the wreath price plus $8. So the mean is $50. So if we looked at the original mean was $42 and the new mean is $50. That's a difference of 8. Okay. Look at the median. I listed out the new wreath prices, found the middle. So the middle is $47. Well, the old middle was $39. But when we added the shipping, the new middle is $47. That's an increase of 8 also. And the mode, there's 247, so the mode is 47. The old mode was 39. So that's an increase of 8. So everything increased by 8. Because we added the same number to each item, that's why it increased by 8. So imagine what's happened here. You can probably do this now. What happened to all of these numbers compared to the original numbers? Well, the original mean was 42, but the new mean with the $5 coupon is 37. That's a difference of 5. The old median was 39, but when we gave everybody $5 off, the new median was 34. and the old mode was $39, but the new mode with the coupon of $5 is $34. So if you're adding or subtracting the same number every single time, that's going to change your mean and median by that same amount. So in this one, everything decreased $5. Okay, because we're adding the same amount to everything, it's going to affect those measures of center. All right, what I'd like you to do is the 8 practice problems to show to me. Hope that answers your questions. See you in class.